Hello everybody, Ian here with another Minecraft video, and today we will be explaining learning target number 17, which is how we can determine whether magma or rocks exist beneath the surface. Now before we get started, we must go over processes we must have learned beforehand. The first one is the process of magma rising, which is convection, where areas of high pressure will go to areas of low pressure, which in return is what magma will do under the stress of when you get towards the center of the earth. The pressure just keeps building up and building up, and as you get farther out from the earth, it will just get more, it'll just get lower and lower. And this process of convection applies to liquids and gases. The next process is, or not really process, but more place, is a divergent boundary. It is where mainly two oceanic crusts open up, and magma using convection will rise up through there and create mid-ocean ridges and new crusts to form. The final one we must know are convergent boundaries or subduction zones, mainly continental oceanic and oceanic oceanic. This is where the two plates collide and one goes down underneath, and basically the friction it creates between the two will create magma, which will then be discussed further later. In the upcoming tutorial, we will be using blocks as placeholders, such as andesite representing oceanic crusts and the oceanic mantle segments. Next is polished andesite and its surface continental crust. Next is stone, which represents underground continental mantle segments. And then the final one is magma, which represents molten rock that exists underground. So the first factor which determines if magma or rock exists underground are volcanoes. Now at subduction zones or oceanic or oceanic continental boundaries, you will find that the friction of the rocks will create heat, and in return the heat will rise up due to convection and will form volcanoes, which prove to us or show that magma does exist underneath the surface through these convection, no, not convection, through convection and these subduction zones. The second factor to this process are divergent boundaries with decompression melting. Decompression melting is where areas of high pressure go to areas of low pressure, like convergent, or not like convergent, like convection. And through this, it does create mid-ocean ridges and new crusts will form, which prove to us that not only the seafloor is spreading, but also that magma does exist underneath. It just cools and creates the crust, since high area to low area pressure movements. The third factor is heat transfer, which is the process of very hot liquids or like lava exist on the surface, which then melt the rocks underneath it, which in return is magma, and will cool. It will go down in the Earth's surface to cool down. But since towards the center or to the mantle, you will find that it gets hotter and hotter once you get towards the center of the Earth. Therefore, it makes it way easier for the surrounding area to then be warmed up from the magma that is coming down to cool off, which in return will bubble up and create a magma chamber. Now let me ask you this. What will happen with the magma chamber afterwards? I will give you some time to answer this question. So I'd like you to pause now. Okay, now that we're back, we will discuss what happens at the magma chamber formed. What happens is, due to convection, the magma will rise up through the ground and actually create volcanoes, which through that process, as we discussed before, convection, it will empty out the magma chamber and make potentially dead volcanoes after a very long period of time. The final process that we will go through that proves magma and rock exist underneath the surface is the process of flux melting, which is uh, places of water and carbon dioxide exist underground, and because of these two substances, it'll make it easier for rock to melt and turn into magma once you get closer towards the center, as we know that it gets hotter once you get towards the core, or the core of the earth. And in return, it will create a magma chamber, which later in time will repeat the same process of heat transfer, which will the chamber will rise up, make a volcano, and then it will empty out over a long period of time. Now that I have finished explaining the video, I will now do a quick um, recap of what we learned about if magma or rock can exist. First, we talked about how volcanoes prove that they exist through underground convection heating. The next process is decompression melting, which areas of high pressure go up to areas of low pressure in this divergent zone model. And then the next one that we learned about was the process of heat transfer, where hot lava will go underground and then the magma will in turn later, once it's all built up, come back up as a volcano. The final factor which we learned are flux melting, which carbon dioxide and water, once in an area, will help rocks melt faster, and in return will create magma and sprout up in a volcano. This now concludes my video presentation on learning target number 17, and here is my source. Alright, you have a good day.